Good evening, everyone. My name is Jyoti Sharma, and this is week 6. And this session will be from 7 to 9. Okay, so what we will cover today. So, first, we will see what difference we have between surface water and groundwater, what different property we have among these two type of water, surface and groundwater, what different technology or mechanism we people use to clean that either groundwater or to clean the surface water. So we will talk about this first. Then we do have a variety of treatment plants. So for example, it is a municipal sewage treatment plant, or you can say industrial treatment plant, etp, that is effluent treatment plant. So we will talk about this different type of treatment plant. Then because we do have a mechanism how we can clean step by step the water, so we will talk at length about primary cleaning and the secondary cleaning. So this will be our topic today. So let's start with the drinking water. That because we do have water from river and water from ground, so we will have some MCQ question on drinking water, and then we will proceed to different mechanism by which we can clean them, right? If you have any query, then you can ask me. Like, you can speak whenever you want to, and you can even write in the chat box whatever query you have. Even if you have any problem understanding the concept, you can let me know, and you people are encouraged to participate, so that by a good discussion we can learn from both sides, right? Okay, so I'm starting with my first question, and this first question is, which of the following correctly differentiate the quality of groundwater from river water as a source of drinking water? So you have to tell me, because groundwater and river water have different property. So which property is aligned to groundwater, and which property is aligned to river water? And I have four options here. Groundwater has constant composition and is generally bacteriologically safe, while river water has varying composition and is not bacteriologically safe. B option is groundwater has high turbidity and variable hardness, while river water has no turbidity and constant hardness. Groundwater contain no minerals, while river water always contain hydrogen sulfide. Groundwater always have iron and manganese, while river water has none of these. So what do you think, what is the right answer? Can you differentiate which one is aligned to the groundwater and which one is aligned to the river water? Any guess? Venkateshwara gave me option A. Okay, yes, I also agree with this option that it is A. And let me show you a table. That table will give you like why the option is A. Good evening, Priscilla. So, if you want to differentiate between groundwater and river, so we do have a lot of parameter. So, for example, either it is safe from bacteria. So, groundwater is generally safe. Let me use my pen. So, the groundwater is safe in the term of bacteria presence, right? And the river water is not that much safe. Lake is safer than river. If we are talking about the composition, what different like if we do have different river, then different river may have different taste, may have different composition. So for the groundwater it is mostly constant, because if you know that most of the groundwater is combined to each other, right? So that's why the composition is constant for the groundwater. But for the river water and lake, it can be variable as per season, as per location where it is. If we are talking about the turbidity, it is near to nil in groundwater, but it is present in river and very less in lake. Mineral, because you know that groundwater have a lot of minerals, so there is the presence of mineral in groundwater, and may or may not be in rivers. If we are talking about the iron and manganese, sometime groundwater have this iron and manganese. River doesn't have iron and manganese, but lake may have. If we are talking about the color, then this is something nil or low. Then the question also had this hydrogen sulfide. So this is sometime present in the groundwater, but it is nil in river and lake. And along with that, we do have a lot of more variables. Okay, so just see here, groundwater has constant composition uh, as per the table, and is bacteriologically safe, while river water has variable composition and is not bacterially safe, and that's why A option is the right one. Okay. Uh, because groundwater is very different from the surface water, then the treatment step will be very different, right? So, which of the following is the first treatment step for surface water compared to hard groundwater? And we have four options here: aeration for surface water, screening for hard groundwater, screening or micro strainer for surface water, aeration for hard groundwater, pre-sedimentation for surface water, oxidation for hard groundwater, filtration for surface water, and recarbonation for hard groundwater. So what would be the first step if we want to clean either surface water or to clean hard groundwater? Then what should be our first step of the treatment? Okay, Priscilla gave me B answer. Uh, that is, it is screening or micro strainer for surface water and aeration for um, hard groundwater. Yes, this is the right answer. And let me tell you why. Because okay, so these are different steps that we have to follow if it is a surface water, because surface water may have something that we can strain out, right? It may be plastic, it may be leaf that has been fallen off from the tree. So we must have to have the screening or the micro stainer to screen out that leaf or whatever thing that we already have put into that surface water. So the first step will be the micro strainer. Then it may be that soil may be present in the surface water, or some of the dust has been fallen off in the in the surface water. So what we have to do is, there should be some pre-sedimentation, or there may be stone or something that because of settling of the dust or larger particle at the base, so this will be the part of the sedimentation. Then we will talk about length about this coagulation and flocculation. Don't worry about this right now. Then again, we will do the sedimentation. It means under the force of gravity, some of the particle will be settled down and we will remove that particle from the surface water. Then we will do the filtration. Then because a lot of organic compound or a lot of chemical that we may have in the surface water, and that we also need to remove. So that's how we will use the adsorption. And after that, we need to remove some of the nutrient. Let's say if we have nitrogen or phosphorus in the water and we do not need it, so we will use disinfection. This is the part of surface water. But if we are talking about the groundwater, first step will be the aeration. But why aeration? Because whenever we are pumping out the water from ground, then it may have some gases present, and that gases can be easily removed by aeration. If we are giving some air to that groundwater, then some of the volatile organic compound that we may have, that can be go out in the atmosphere, and this is how we can remove some of the volatile organic compound from our groundwater. Because in under pressure in groundwater, we may have some of the such kind of gaseous pollutant. Then the first step will be aeration. Then we have oxidation, using oxidizing agent, or pre-chlorination we will do. Then, because groundwater has a very special feature, that is the hardness. It has hardness due to calcium and magnesium. So to remove that hardness, there is lime or soda addition. So we have to add this so that the hardness can be removed. Then, in the form of precipitation, and that precipitation will be removed, or skimmed out of the groundwater. Then we will have sedimentation. Then we will do the recarbonation, because I have one MCQ on recarbonation. I'm not telling you right now why we are using this recarbonation. Then we have filtration and disinfection. So just see how different step we have to adapt for surface water, cleaning of surface water, or to clean the groundwater. If you have any problem with this step, you can let me know. Otherwise, I have a lot of question on this surface water step, so I may have one or two question on screening, one or two question on rapid mixing, then slow mixing, then sedimentation, filtration, and disinfection. So maybe I have 10 to 12 question related to these step of the surface water. If you have any problem right now, you can let me know. Otherwise, we can go with this MCQ question. Is it clear? Can anybody write in the chat box whether it is clear?
Yes, ma'am.
Okay, thank you so much. Thank you, Priscilla. Okay, so now my first question is, which treatment step is unique to hard groundwater treatment but not present in surface water treatment? And pre-sedimentation, recarbonation, filtration, adsorption for organic removal. We have seen these steps, right? So can you tell me which step is very unique to the hard groundwater treatment? Not D. You can change your option. Which step was very unique to the groundwater and that step is not present in surface water treatment? No. Yes, B is the right option. So this is recarbonation. Let me show you actually. So we studied this, right? And I asked which step is unique for the hard groundwater. So this is recarbonation. Sedimentation is same, filtration is also same, disinfection is also same. This is unique for the surface water, and this is unique for the surface water. But I asked which step is unique for the hard groundwater, and this will be the recarbonation. So that's how here the option B will be right, not A and not also D. Priscilla, I have one question about this. So I'm waiting for that question so that I can explain about recarbonation for that particular question. Can you please wait a little about like till that question comes? Okay, thank you so much. Okay, so because we are talking about surface water, then this is the surface water. There is a micro stainer. Using that micro stainer, we will strain that water. Then we will have coagulation, flocculation. We have next two or three question about this coagulation and flocculation. Then we have sedimentation. After that sedimentation, we have filtration, disinfection, storage, and the distribution. So now my question will be on these things. So you have to tell me question about coagulation, flocculation, sedimentation, filtration, and all. And among that only you will have recarbonation. Okay, because one of the problem that we have in the surface water is that we have some particles, colloidal particle in that surface water. So can you define that colloidal particle in the water? What that it mean? So they are large particles that settle quickly under gravity. They are usually positive charge, leading to stable suspension. They are small, usually negative charged, and cause stable suspension. They are formed only after coagulation and flocculation. Priscilla gave me answer C. Okay, Venkateshwar also. Yes. So I'm also agreeing with this. So these particles are very smaller in size. So this size is 0.001 to 1 micrometer. These are negatively charged. This is very important because whenever we are talking about coagulation step, so this charge is very important. Just keep in mind, and that will cause the stable suspension. So C is the right answer. And you can see here the colloid. So colloid is mainly the mixture of microscopic particles that are suspended in another medium. So for example, if it is a milk, then some protein or fat, these are solid in nature, are dispersed in liquid. So like medium is different. So milk is nothing but it is a colloid. If we are talking about the smoke, then this is within the gas we have some solid particle. So this will again will create the colloid. Then gelatin. So just you can keep in mind what does it mean. Okay, so what is the main goal of coagulation in water treatment? So we have four options: to remove dissolved salt directly by chemical reaction, to alter the surface charge of colloidal particles so they can adhere and settle, to sterilize microorganism by chlorine addition, to reduce hardness by lime soda softening. So the one of the step in to clean the surface water was the coagulation. Now we have some question on coagulation. Venkatesh gave me answer B. Yes. So I also agree with this. So the answer will be B. So the thing is that, as I told you, for example, we have surface water, and that surface water is, let's say, in the beaker, and that have the colloidal particle. So these are suspended in the liquid. And if we want to remove this, because they are very stable, right? Because in that uh, last slide, you showed that these they cause stable suspension. It means they are not settling down, right? So because of that we have to settle them out. And how we can do settle them out? Because colloidal particle have the negative charge, right? Have the negative charge. So we will add some chemical, and that chemical is known as coagulants, and that coagulant will have positive charge. So what will happen? This negative charge will react with the positive charge and will make neutralization, right? So there will be no any charge later. So whenever we are adding coagulant in any surface water, whatever colloidal particle we had that had the negative charge, that will react with this positive charge coagulant and will neutralize this solution. And this is how we can settle it down. Ma'am, can we add ice cream as example? Ice cream, not that much, but you can search. Like, I do not have much idea whether we can call ice cream as a colloidal solution or not. But you can search about this and you can let me know. But I don't think so. Um, Venkateshwara answered that it is no. Then you can talk with Venkateshwara about this, why he said no. Anyway, so just see here. We have these are impurities, and impurities means it can be anything that has been suspended in your untreated water and that have the negative charge. And if we are adding coagulant, that what it will make, this will reduce their repulsive charge. So the thing is, why they are stable? So their stability is because these are negative charged, and there is a kind of repulsion to each other, and because of the repulsion, this suspension is very stable in nature, and that's why they are like they are not settling down. Okay, but if we are adding coagulant, then this will remove this negative charge and will neutralize this. So this will reduce their repulsive charge, and this will form some flocks. And after that, these flocks will be formed, and this we can remove by sedimentation or some another step that we will discuss. So I think you right now, you people are now aware why we are using coagulants, or why we do have that step coagulation in to treat the wastewater or to treat the surface water right now. Okay, so next question is, which of the following is the key reason for using alum as a coagulant? And we have four options. It is toxic but react quickly at all pH level. It is non-toxic, inexpensive, and insoluble in neutral pH range. It releases calcium carbonate to reduce hardness. It is effective only at pH above 9. So I got B option, and yes, B option is the right one. So we do have a lot of chemical that we can use as a coagulant. One of them is alum. And why we are using alum in a large quantity, that is because it is non-toxic, inexpensive, and it is insoluble in neutral pH range. That's why most of the time, or popularly, we are using alum as a coagulant. And here you can see, this is your alum, right? Alum will create uh, this one cation. So this is aluminium cation. It will release, and then sulfate and water. These cations, because it has 3 plus, right? So it can neutral three negative charge collides. Okay, or three electron it can take, and it can react with this one so that it will neutralize the surface charge. So this is how alum works. Okay, but there are some condition when to use alum, or when what should be the proper condition. In that condition only we can use alum. And the thing is, we should have sufficient bicarbonate in the surface water, then only we can use alum. And if we do have sufficient bicarbonate present in surface water, what is the main reaction product when alum is added to water? So we have aluminium hydroxide, aluminium oxide, then this is sulfur oxide, and then aluminium chloride. Okay, I got A answer, and yes, A answer will be the right one. So this will create aluminium hydroxide that will form some flocks, and this is how we can remove the turbidity. And I have equation for this. So if we have aluminium and we have bicarbonate, then this will react and will form aluminium hydroxide and CO2. Next is, what will happen if we do not have sufficient bicarbonate in your untreated water during alum coagulation? No reaction occur and colloids remain suspended. Aluminium hydroxide and sulfuric acid form, which lower the pH. Alum dissolve completely, leaving excess aluminium cation ions in water. Flocculation continue unaffected by bicarbonate levels. Okay, so I got B option. Priscilla gave me B option. So yes, if we do have insufficient bicarbonate, and if we are adding alum coagulant in your untreated water, so there will be some reaction, and that will create sulfuric acid, and that will lower the pH. It means your water, untreated water, will be acidic in nature. So again, we have reaction for this. Uh, we have alum, and if we do not have bicarbonate, then this will create, no doubt, aluminium hydroxide. But along with that, it will create sulfuric acid also, and this will lower the pH. So whenever we are using alum as a coagulant, we have to have bicarbonate in a sufficient quantity. Okay, which of the following are commonly used coagulants in water treatment? Alum, ferric chloride, ferric sulfate, polyelectrolytes, sodium chloride, calcium carbonate, potassium hydroxide, chlorine gas, ozone, ultraviolet light, activated carbon, silica, and zeolite. Acidic is because of sulfuric acid, because sulfuric acid will be formed in your surface water. So sulfuric acid will give you the acidic nature of the water. So that's why whenever we have to add uh, this alum coagulant in the water, we have to uh, add bicarbonate so that pH can be maintained, because bicarbonate is basic in nature. Okay, so this will be basic, and then we have alum that may create sulfuric acid, so that's how it will neutralize. So can you tell me some of the example of coagulants that we can use in water treatment? Priscilla gave me A, and Venkateshwara also gave me A. Yes. Dia also gave me A. So yes, we have talked about this now. Alum is the one of the popularly used coagulant, right? So along with alum, we can use ferric chloride, ferric sulfate, and we can also use polyelectrolyte as a coagulant. So just keep in mind, the work of the coagulant is to neutralize the suspended particle. Okay. The next question is, which of the following currently correctly describe rapid mixing condition? If you know that coagulation is done, or is happened in rapid mixing. Okay, so you have to tell me correct about this rapid mixing condition. Retention time of 10 to 15 minutes carried out by horizontal impellers without baffles. Retention time of 1 to 2 minutes. No retention time. Retention time of more than 30 minutes. So the thing is that if we have coagulant, right? If we are adding coagulant in your surface water, we have to rapidly mix it. Okay, this is something that we are talking about, rapid mixing condition. But the thing is, for how much time we have to do this rapid mixing, this is very important for us. So retention time of 10 to 15, 1 to 2 minutes, no retention time we need, or retention time we need for more than 20 minutes. Okay, Priscilla gave me B with the question mark, and Venkateshwar A. Okay, I will go with B only. So, because we are doing rapid mixing, okay. So for that rapid mixing, we have to just give 1 to 2 minutes. So the retention time will be 1 to 2 minutes, and that we have to done using vertically shaft. So we have some blade kind of things that are vertically. So with that, we have to do this rapid mixing, and the retention time will be just 1 to 2 minutes. Let me show you if I have the picture of this. So can you see this? This one is a realistic picture. So with that buffers, we have to mix it rapidly, and the time will be 1 to 2. So just see here, we are adding coagulant, and then we have to do this rapid mixing. Okay, so this is the first step of the coagulation. The next step will be the flocculation. We have some question on flocculation. Okay, so the next question is flocculation. So in the flocculation step of water treatment, why are pedals rotated slowly? To maintain turbulence and break up large flocks, to allow gentle collision of destabilized particles so they form large flocks, to increase the oxygen content of water, to remove gas such as carbon dioxide and hydrogen sulfur. Okay, Priscilla B with question, Dia B, and Venkateshwara B. Yes. So because you already have given me B option, then how I can decline your request to be the B answer. So yes, this is the B. So what is happening is that uh, to mix that coagulant, we are doing the rapid mixing. But after that 1 or 2 minutes, we have to do slow mix it. But why this is slow? Okay, it is a guess, but nice guess. Then why we are doing this? So this is something because we do have neutralized flocks, right, or neutralized particle. So if we will do the slow mixing, then one neutralized particle will have the collision with another one. Okay, and this is how it will form some flocks, and that flocks we can remove by sedimentation. Okay, but what if we will do it rapid? Then because of that rapid, the flocks will be broken down, right? So we are not using rapid mixing, but here for the flocculation we are having slow mixing. Because of that slow mixing, flocks can be formed, and that flocks we will remove in the sedimentation. So this is something to allow gentle collision of destabilized particle so that they can form large flocks. So that's how B is the right answer. And here also you can see, whenever we added coagulant, then this coagulant will destabilize this particle, and then after slow mixing, they will form the flocks. They will form the flocks, and these flocks, because that flocks may have some density and that can be settled down. Okay, so this is the principle how we can remove the colloidal particle from the surface water. Again, you can see the same picture. We have the rapid mixing in the coagulation, but in the flocculation we should have very slow mixing. And because uh, flocks will come down in the sedimentation and it will be removed, and the treated water will go further for the treatment. Okay, now you again have to tell me what velocity, what pedal speed or detention time we should give for the flocculation. So A option is pedal speed 5 to 10 rotation per minute, a water velocity 0.2 to 0.5 meter per second, and detention time is more than 20 minutes. In B, detention time is less than 2 minutes. In C, detention time is not given, and for the D, detention time of only 2 to 5 minutes. Venkateshwara and Priscilla gave me A answer. Okay, yes, I also agree with this. Uh, so this is A. So the paddle speed should be less than 5 to 10 rotation per minute. Water velocity should be very low because we are allowing the destabilized particle to collide. Okay, we don't want to break it down, so that's why the water velocity should be very low, and we are giving more time so that flocks can be formed. So here we are giving more than 20 minutes for the flock formation, and that will come under the flocculation. Okay, next question is which of the following correctly describes sedimentation condition? Okay, so we talked about coagulation, we talked about flocculation. The next step will be the sedimentation. So you have to tell me what correctly describes a sedimentation condition in settling basin. We have four options here: high turbulence, water retained for less than 30 minutes; nearly quiescent flow, water retained for at least 30 hours; flocks settle at the bottom; rapid mixing with impellers, water retained for 1 to 2 minutes; slow pedal mixing, retention time about 20 minutes. Okay, so your question is how they remove sedimented coagulation from dam or river stream. Okay, so the thing is, because whenever we are diverting the river or dam water to the household, that water we have to store somewhere. Okay, so uh, after storing or before storing, but the thing is, before diverting it to any house or to the household, there are large chamber or large area where uh, this kind of facilities is provided. So at that place only we have to do such kind of steps. So this is something like uh, we are not diverting river water directly to the house, but we are storing, or before diverting it to the house, we have to gone through these kind of steps. So there are large area in which we have to divert firstly the water from river, and then we have to do the treatment, and then we will divert it to the household. So options what I'm having is a Venkateshwara, B, and then A. Okay, so the option is B. So just think about this. We talked about coagulation. Coagulation is just to stabilize. Okay, flocculation, it means we created the flocks. Okay, the next step will be to give some time so that these flocks can be settled down at the bottom, and this can be removed from the bottom by scrappers, and this treated water can be treated further. So this is the sedimentation. So here what we have to do is the flow should be very stagnant. There should not be any flow because we are keeping that water still. We are not moving that water. So there should be no flow. Water should be retained at least for 3 hours. And that's how these flocks will settle at the bottom. So this was your third step after coagulation, flocculation, and then sedimentation. So that's how B answer is the right one. We are not allowing the high turbulence because high turbulence means settling will not happen. So that's why A is not the right answer. Rapid mixing, no, we don't want to move the water. We have to keep that water stagnant so that settling can be happened. So this is also not the option. And we are not moving, we are like the water will be stagnant, so this will also not the answer. So B is the right answer. So as I discussed, first we have flocculation, then we have some settling basin, and based on that, we will have another will be we will use filter in the next step. Okay, after sedimentation, so sedimentation is done. Water typically has a turbidity of 1 to 10 NTU, which is the desired effluent turbidity after filtration. So after sedimentation, we are having the filtration. Okay. After that filtration, turbidity value should be what? Priscilla gave me C answer. Okay. So yes, C is the right answer. That should be less than 0.3 NTU. Okay. because right now we have moved to the filtration step, right? So we do have different type of filtration can be mechanical in nature, biological in nature, we can have adsorption, we can use multimedia filters, right? But you have to tell me which filtration have the correct description in this four option. So mechanical staining occur in slow sand filter, dual media filter use sand only. Removed by microorganism in top layer of slow sand filter. Adsorption occur only in disinfection stage, not in filtration. Multimedia filter made of sand only. So we have different way by which we can do the filtration. It can be mechanical, it can be biological, it can be adsorption, it can be using multimedia filter. But you have to tell me which has the correct description. Mm, Priscilla gave me B answer. Okay, so yes, I also agree with the B, because if we are talking about biological, then obviously it will be a slow sand filter, and on the top of that, we will have some microorganism. So whenever we are having water that is percolating through that filter that have the microorganism, this is how we can remove some of the nutrient or some of the biodegraded material out of this surface water. If we are talking about the mechanical straining, then I will show you here. This is right one, but dual media filter use sand only. No, because it is dual, right? So it is not just the sand, but another material also we can use. For example, charcoal. For example, anthracite. So we can use in dual media. And adsorption occur only in disinfection stage, not in filtration. No, adsorption can also occur in the filtration stage. And in multimedia filter we can use different type of chemicals or the material by which we can create multimedia filter, but not just the sand is one of that part, right? So that's how B is the right answer, and I have some explanation for this. So we have mechanical staining, and this mechanical staining is based on like the void space. So this is something like this straining that we have to do. Then biological, that will remove the microorganism. Adsorption, and then adsorption to filter media, and there will be sedimentation on filter media. And we can use single media, we can use dual media, we can use multimedia for this filtration step. Okay, the next question is, how is backwashing of rapid sand filter usually accomplished? By scraping off the clogged top layer of sand and replacing it, by forcing water upward through the filter to suspend media and release trapped solid, by draining all water and leaving the filter empty overnight, by reversing the sedimentation process. Okay, so Priscilla and Dia gave me B option. Yes, so this is B. So it is something like this. We have some strainer. Okay, so that strainer has been clogged with something like solid. Then what we have to do, we have to do the backwashing, so that this solid can be removed from that strains, right? So this is something like this. So if we have any filter and that filter will be clogged with the solid particles, so we do have the uh, backwashing, and we can also give that some air from the back, so that we can remove or we can clean that pores of the filter. So that's how B answer is the right one. Okay, so the next step to treat the surface water is disinfection. Okay, and Disinfection can be done by various way. One is ozonation and another is chlorine. If you have heard that, uh, uh, before this RO and all, we used to treat our water with the chlorine. So this is chlorine disinfection. And right now we people are using advanced technique, that is the ozonation. So you have to tell me the advantage of ozonation over chlorine disinfection. And we have four option here. Ozone produce stable organic chloride that improve taste. Ozone substitute chloride, remove color and odor, and does not form harmful chlorinated byproduct. Ozone have high water solubility and remains stable for long period. Ozone reduce hardness by precipitating calcium carbonate. Okay, everyone already have given me the B answer, so I should not waste much time on this. So yes, B is the right answer, because whenever we are using ozone, so that will remove that color and odor that was whenever we were using that chlorine based water. And the another limitation and even advantage of the chlorine was that it is producing the chlorinated byproduct. So this chlorinated byproduct, disadvantage was that, because you are having, you have to have this chlorinated byproduct along with the water in your body. So this was the disadvantage. But advantage was that, uh, for the long for the longer time, because we already have chlorinated byproduct, so for the long time your water will be safer to use, because over the time this chlorine particle will disinfect your water. But to replace this a part, we are using ozone, because that are neither creating this color nor this odor. Okay, so we started from here, right? Surface water, then coagulation, flocculation, sedimentation, filtration, disinfection, and after disinfection, we will store that water and we will distribute that water. Okay, this is we have learned about the surface water, right? And so this part is completed. Screening, pre-sedimentation, rapid mixing, slow mixing, sedimentation, filtration, little bit about this adsorption and disinfection. Now this one is, because we already have talked about this filtration, disinfection, sedimentation. So we have a very few question on this hard groundwater. Okay. And now the thing is, even then, after these all steps, we can't use that surface water directly to the home to drink that water. So to drink that water, we have some techniques. For example, we are using RO. We can use ion exchange method. That is again along with the RO that we can use. So the one question is on reverse osmosis. So you have to tell me the correct statement about this reverse osmosis. So reverse osmosis remove only organic contaminant but not dissolved salts. RO remove nitrate, sodium, dissolve inorganic and some organics, but not all contaminants. RO is mainly used for softening water by removing calcium and magnesium. RO is ineffective for removing false smell, taste, odor, and color. Dia gave me C, but you have chance that you can change your option, because C is not the right option. Priscilla gave me B. Okay, so I agree with B option, that it can remove uh, some of inorganic compound, for example nitrate, sodium, dissolved inorganics. But if and some of the organic, but it can't remove all the contaminants that we have. So this is the limitation of RO. If we are talking about the C option, softening water by removing calcium and magnesium, this is very difficult for RO to remove this, to remove this hardness. This is the hardness, right? To remove that hardness, we should have ion exchange technique. Okay, so that's how C is not the right answer, but B is. So just see here, we can remove nitrate, sodium, inorganic or organic compound. We can remove foul smell and color also. We can improve the taste. It can also reduce some level of pesticide, dioxin, chloroform, and petrochemical, but it can't remove all of these contaminants, right? Some of them, some of that it can remove. Okay, along with RO, people are also using activated carbon in the household filters. So, what is the main function of activated carbon household filters? We have four options here: removal of nitrates and dissolved mineral, absorption of organic contaminant causing taste and odor problems, softening water by removing calcium and magnesium, reduction of fluoride and radium. Let me see the answers. Priscilla and Divya. Okay. Uh, Divya gave me B and Venkateshwara also gave me B. So yes, the activated charcoal we are using everywhere, right? We are using in face wash, we are using in any of like face mask, something like this. So we are using activated charcoal in many of these. The main purpose of this activated charcoal is absorption. So it can absorb organic contaminants, and by which we can remove the odor and the taste. We can improve the taste. So that's how B option is the right one. So just see here. So this is how we can use activated carbon, and we can filter the water. Okay, and there is some limitation also. So no doubt it is efficient in removing metals such as lead or copper, but it can't remove nitrate, bacteria, or dissolved minerals. So that's why, uh, along with activated charcoal, we have to use RO as well for to clean the drinking water. Okay, so next question is major limitation of ion exchange. So we have RO, we have activated charcoal to treat the drinking water. Another is the ion exchange. So can you tell me the major limitation of ion exchange? They cannot remove calcium and magnesium from hard water. They remove chlorine byproduct, but not pesticide. The resin become coated, clogged if water contain oxidized iron or iron bacteria. They are unable to reduce fluoride content in water. Priscilla gave me answer C. Okay, so yes, answer is C. Let me show you. So this is something like this. We are having some resins. Okay, so that resin with let's say sodium attach. So what can happen? This sodium will be released, and uh, in the place of sodium, calcium and magnesium ion will be attached. So this is how we are exchanging the ions. We are releasing sodium, but what we are doing, we are absorbing that calcium and magnesium, and this is how ion exchange is very effective in softening the water, because we are removing this calcium and magnesium, and we are releasing some sodium ion into your water. So this is how it can do. But the thing is, as soon as this resin will be saturated with the calcium and magnesium, we can't use it, right? So the thing is, this will be clogged. So we have to replace this resin of this ion exchange. Otherwise, we have some processes by which we can again replace this calcium magnesium with some another chemical, and we can create one another the same original ion exchange resin, right? So but because we are using it into our home, that we have to replace this. Whenever there will be the clogging, then we have to replace it. So this is the limitation of ion exchange. So there are some limitation, and these limitations are ion exchange resin will be coated or clogged, and it will lose its softening ability. So whenever we are using RO, so most of the time, to treat the drinking water along with RO, we have to use this ion exchange. Along with that, we also have to use ultraviolet radiation to kill the bacteria and all. So whenever such kind of combination we have within a single unit to treat the drinking water, then we can say water is little bit safe to drink the water. But yes, there is a lot of debate why whether we should use RO or not, because some of the minerals that we have from the groundwater or from surface water are essential for us. Okay, and this RO or ion exchange will remove that important minerals or nutrient from that water. So there is a lot of debate whether we should use RO or not, but it is actually based on the water source or the property of water that you want to treat. Okay, so based on that, you have to see what unit we need to treat our drinking water. Anyway, so okay, I don't know where is that question of the. You were talking about recarbonation, right? So I don't think that right now there is a question, because we are moving to the next unit, so that is domestic and industrial wastewater. So recarbonation is because we were using lime and soda. Okay, we were using lime and soda in the groundwater to remove the hardness. Okay, to remove the hardness, we were using lime or soda addition. We had third or fourth step like this. So because of this lime and soda, the pH will be increased, basicity will be increased. So to neutralize again, we have to add carbon dioxide. So this carbon dioxide will reduce pH a little bit, so that it can neutralize the water pH. Okay, so that's why we are using a recarbonation. But I don't know why there is no question. But anyway, so, okay, you talked about the surface water and the groundwater. Okay, coming from the river, and we already have discussed some step that we can have to treat that water. But what will happen if that water is coming from home, or that water is coming from some industries? Okay, so yes, we have to take some of the step to treat that water, and we have some unit that is known as the treatment unit. So this treatment unit may be sewage treatment unit or plant, so that is known as STP. If it is coming from the industries, then it will be ETP, so this is effluent treatment plant. And along with that, so this is effluent plant. Then if we are not sure from where this water is coming, either it is coming from home or from municipal, or it is coming from the industries, or it is taking larger area to treat that water, so the one of the facility will be CETP. So where we can treat all such kind of water. And in that treatment plant, whatever the steps we have discussed, such kind of step will be used only, but in a little different way. Okay, so we have some of question on this treatment plants, and then we will move on basically on primary treatment and the secondary treatment. So just see here, we have wastewater treatment, and this wastewater treatment we have to do it. This is the on-site disposal. Then we have domestic wastewater or sewage treatment, STP, ETP for the industrial wastewater, and this is common effluent treatment, CETP. Just keep in mind such kind of treatment facilities that we have. For that, we have very extensive steps, like within Okay, so in your surface water you had just filtration, coagulation, flocculation, sedimentation, then disinfection, right? But in wastewater treatment, right now we are talking about the wastewater, we are not talking about the stream water or groundwater or surface water, right? We have now wastewater. So for wastewater we should have primary and secondary treatment, and you have to tell me what happened in the primary treatment and what happens in secondary treatment. So okay, let me see. Priscilla, Divya, Venkateshwara, everyone gave me C answer. Yes, I also agree with this. So in the primary treatment there is a sedimentation and flotation, we will talk about this. And in secondary treatment we have activated sludge and biological filter, we will talk about this as well. So after this treatment wala unit na, so we will discuss about this primary treatment and secondary treatment at length. So just see here, if we do have sewage water, then this part is the primary treatment. We are using screens, we are crushing that. For example, we have some container, we have plastic, so we also have to crush that also. Then we are using grit chamber, then we are using primary clarifier, and then after this water will go on to the secondary treatment. So in secondary treatment, we are using some microorganisms. Okay, and then we will have the disinfection. This will come under the tertiary treatment. So these three steps we have to follow if we want to treat the wastewater. And within this primary and secondary and tertiary, we have a lot of steps that we have to follow. So, okay, even before primary treatment, we have to undergo through preliminary treatment, so that some of the instrument that we are using in the primary treatment are not much affected. So we are using here uh, screens and some grates to remove the large particle. We are also using communators for a grinding of coarse solid, and pre-aeration we can also give so that odor can be removed. Then we have primary treatment, in which we have sedimentation chamber, we have flotation and the flocculation. Then in secondary treatment, we can have lagoons, we will talk about this. We can have activated sludge, we will talk about this. We can have biological filters. Then in tertiary, we can have ozonation, adsorption, RO, membrane separation, ion exchange. We will talk about this. So these are the different steps that we have to take. Okay, so if we are doing the primary treatment of sewage, approximately how much BOD and suspended solids are removed? 85% BOD and solid, 90% BOD and solid, 60% solid and 35% BOD, 20% solid and near to 10% BOD. BOD is the biological oxygen demand or biochemical oxygen demand. Venkateshwara gave me answer B. Priscilla also B with some question mark. Okay, but the answer is C, because here what we are doing, we are just having the primary treatment, and the primary treatment was just the sedimentation, flocculation, and coagulation and all. Here we are not removing organic compound. Okay, so here BOD will be near to 35% of the BOD will be removed, and 60% of the solid, because here we are not using microorganisms, so BOD will be just 35% will be removed. Okay, now you have to tell me treatment efficiency about the primary treatment, about the tertiary treatment, and about the advanced treatment. So primary treatment remove 85% BOD while secondary remove 60%. Secondary treatment remove 85% of BOD and solid while advanced treatment can remove 95% including nutrients. Advanced treatment remove less than secondary treatment because this is optional. Pre-treatment remove 90% of BOD and solid. So Dia gave me a B option, Venkateshwara with B and Priscilla with B, but along with a question mark. But yes, you all people are correct that this is B. Advanced treatment remove less than secondary treatment. No, this is wrong. BOD is mostly removed by this secondary treatment. Pre-treatment remove 95%. No, pre-treatment is at all not removing this BOD. So this is also not the right option. Pre-treatment remove 85% of BOD. No, this is near to 35%. So that's how B option is the right one. Okay, so this is something we have. If we have the pre-treatment, so that will remove only the material that can cause operational problem, and that will have one step, that is the equalization step. In the primary treatment, 60% of solid and 35% of BOD will remove. In secondary, 85% of BOD and solid, and in advance, 95% of the BOD and solid, along with nitrogen and phosphorus will be removed. So these are your pre-treatment steps. We are using bar racks, we are using grit chamber, we are having equalization basin. In the primary treatment, we have the primary settling chamber or settling process. In the secondary treatment, we have biological treatment and the secondary settling. In the tertiary treatment, we are using advanced waste treatment. So we will talk about this one by one so that you have some clarity about each of these steps. Okay, so this question is about the tertiary treatment method that is specifically used for the purification objective. So, can you find out which one is the tertiary treatment method? Dia gave me answer C. Okay, if we are talking about this sedimentation, filtration, and flotation, this is the part of primary treatment. Activated and lagoon is the part of secondary treatment. This one is the right. Ozone, RO, and ion exchanges for the tertiary treatment. And flocculation and biological filters. So this is again the part of primary treatment. So C answer will be the right one. Okay, so if you want to establish treatment plant, effluent treatment plant, industrial effluent treatment plant, so which site is acceptable for locating that industrial ETP? Flood prone area, wetland, aquifer recharge zone, elevated dry land away from water supply wells or reservoir. So I think this is very simple. And Divya and Priscilla gave me D answer. Then obviously answer will be D. And why D? Because that is the wastewater, right? So if we are having wastewater from the industries, we should not have any. We should not have the contact of groundwater with the wastewater. Okay, so if it is a flood prone area, it means your wastewater will be moved along with your flood water to the river or to the ocean. So this is not acceptable. If it is a wetland, then your wastewater will be merged with your groundwater. If it is the aquifer recharge zone, then again it will be mixed with the groundwater. So we do not want to mix it either with the groundwater or to the river water. So that's why we can't locate our ETP at such kind of location, but it should be at the dry land and which is away from a water supply or well or reservoir. That's why B is the right answer. So just see here, the site must not be in aquifer recharge zone, flood prone. We already have talked about this three. Seasonally high water table and proximity to water supply wells and reservoirs. Okay, next coming, if we want to remove some organic from this ETP, using this ETP, effluent treatment plant, then the recommended BOD and COD ratio should be what? Okay, Diya and Venkateshwara gave me answer C. So yes, this is C. So whenever we want to remove some organic compound, so we first have to see the BOD and COD content, and if it is equal to or greater than zero point 0.5, the ratio is equal to or greater than zero point 0.5, then we can effectively remove this organic compound in an ETP. So C answer is the right one. So here it is also written, uh, it is good whenever we have ratio 0 0.5 or greater. The main purpose of common effluent treatment plant is to treat only domestic sewage from urban area, to provide collective treatment for effluent from small scale industries in a cluster, to replace municipal sewage treatment plant completely, to directly discharge untreated wastewater into river. Okay, so everyone gave me a B answer. So yes, we can have the wastewater from small scale industries, and we can collect it in a cluster, and then we can use a common effluent treatment plant to treat all of this water. So that's how B answer is the right one. So this is how it look likes. You have seen, if you are uh, in Delhi, a lot of uh, CETP we have. So such kind of clarifiers, tanks, and a lot of tanks we have, and based on that tanks you can identify this area is for the treatment. Okay, so we have talked about how we can clean surface water, how we can clean groundwater, and then what different treatment plant we have to treat the wastewater coming from your home, coming from industries, right? Now we are focusing more on primary treatment, what different equipments we have in the primary treatment and then in the secondary treatment, and this is how we will complete our session. So this coming 10 to 15 questions are based on your primary treatment equipments. So just see what different equipment we use. So we use bar rack, we use bar screens, we use grit chamber, equalization tanks, sedimentation tanks. These are the equipment that we use. Then there are different type of settling in the sedimentation tank we may have. That can be discrete settling, that can be flocculent settling, and that can be zone settling. If we are talking about the design aspect, then to design this grit chamber, or to design this clarifier, or to design this gas flotation, we must have some engineering. Okay, so we will talk little bit about this portion as well. So the coming question will be based on your primary treatment equipments and the conceptual questions related to it. Okay, lengthy MCQ, but you have to tell me a correct statement about bar sex and bar screed in wastewater treatment. So this is very first step that we have whenever we have polythene or tin container or whatever we have, first we should have bar racks or bar screens so that uh, this can be removed. Such kind of things can be removed from your wastewater. And you have to tell me the correct statement about bar racks and bar screens. So, bar racks are conveyor operated system that automatically remove screenings, while bar screens are manually racked rough screen with 3-inch spacing. Bar racks are rough screening device with parallel bars, while bar screens are finer, often motorized filter that can operate continuously and intermittently. Bar X are always horizontal filters in channel, while bar screen are always inclined and only used for stormwater. Uh, that's how. Let me see the answers. Okay, so I have Priscilla gave me B and Venkateshwara also gave me B. Yes, so B is the right answer. So what we have, first we have the bar racks. So that have the screening device. So these are the parallel bars, something like this. So whenever water will come, so using this bar we can remove the compound, remove the material that are bigger in size. Then we have bar screens. So bar screens are like this. So these are very fine, of a motorized filter, and we can operate it continuously. So this is the true statement about bar racks and bar screens. Something like this. Okay. A wastewater treatment plant faces frequent clogging of pumps due to rags, wipes, or plastic. Which device provide the most suitable first level filtration? Bar rack, bar screen, grit chamber, or primary settling chamber, uh, settling tank. Mm, okay, B with question mark. One answer I got from Priscilla. B with question mark. Venkateshwara B. Okay, so yes, B answer is the right one. So we have bar screen that will remove finer debris and that will protect our pumps from clogging. And grit chamber will be used later, but it is not for the racks, wipes or plastic. It is for settling out some dust or something like that, large particle. And settling tank is for the further fine particles. So these are the next steps. But bar racks, these are not much finer. So bar screens will be used so that we can protect our pumps from clogging. Okay, so the next is grit chamber. So we have chamber and we have water in it, right? And you have to tell me, why must the flow velocity in the horizontal grit flow grit chamber be carefully maintained at about zero point 0.3 meter per second? And we have four options here. To allow organic biodegradable solid to settle with grit, maximizing the BOD removal. To prevent organic matter from settling while still allowing heavier grit particle to settle. To ensure flotation of light material like grease and oil. To accelerate removal by turbulence and scoring action. What do you think? Why we are maintaining the flow velocity of zero point 0.3 meter per second in your grit chamber? Any option? Any idea? Why we are having the flow velocity very less, zero point 0.3 meter per second? Mm, Okay, so Venkateshwara A with uncertainty, uh, Diya with B, and B with uncertainty. Okay, so you have some problem with this question, but the right answer is B. So just see here, we are having the water is not stagnant. Water have some velocity, and that velocity is very low, 0.3 meter per second. And that is because we do not want to prevent organic matter from settling, but we are also allowing heavier grit particle to settle. So the thing is, whenever we will have secondary treatment, in that secondary treatment we will degrade that organic matter. So this is not the right time where we need to remove this organic matter, but we want to allow this heavier grit particle to settle. So that's why we are using, we are having very less velocity. So this is how it look likes. Uh, this is your grid chamber in real way, and this is a schematic diagram. Okay, a treatment plant is experiencing heavy wear on pumps despite installing sedimentation tank. What is the most like cause, and which unit should be emphasized? Improperly designed bar screen should use finer screen. High concentration of organic solid, increased detention in primary clarifier, presence of heavy inorganic material like sand and gravel, improve grid chamber efficiency, poor biological decomposition, optimize aeration tank. Okay, Priscilla, Venkateshwara, they gave me C answer. Then yes, C answer is the right one. This may be because of heavy inorganic material. That we have sand or gravels, and that's how we need to improve our grid chamber efficiently. Okay, why is air introduced in aerated grid chamber? So initially we were using grid chamber only, but we can also use aerated. So we can give some air to that chamber uh, at 0.15 to 0.45 meter cube per second per meter of tank length. But why we are using air? To increase dissolved oxygen for biological decomposition of organics in the grid chamber, to create a spiral flow pattern that keep lighter organic in suspension while heavier grid settles, to enhance coagulation and flocculation, or to strip out volatile gas like hydrogen, sulfur, and methane during pretreatment. Priscilla gave me B with the question mark. Okay. So yes, B answer is the right one. So why we are using this? So we use air so that I have one picture. So this is something like this. So that we have helical pattern, and what this helical pattern will help us, so that because we know now we are having the velocity less than or near 2.3 meter per second. Why? Because we want to our organic matter in the suspension, and we want to remove the larger particle to settle down. And this kind of categorization can be enhanced whenever we are giving air to your grid chamber, and this is how it will have the helical pattern, and same can be happen with efficiency. Okay, so in aerated grid chamber is designed with liquid retention time of 3 minutes at maximum flow. If actual retention time is significantly longer, which undesirable effect is most likely? Liquid retention time is just for 3 minutes, but what will happen if we are increasing this retention time? Grit will pass through without settling, reducing efficiency. Excessive organic matter will settle along with grit, leading to septic condition and odor problems. Spiral flow will break down, reducing grit removal efficiency, and dissolved oxygen will be depleted too quickly, making the chamber anaerobic. So Priscilla gave me answer B. Okay, I also agree with B. From very starting, we were very clear why we are using the grit chamber. So the purpose of grit chamber was that we have some grit or the large particle material that we want to settle down, but we have organic matter that we want in the suspension. Why we want to keep that in suspension? Because in a secondary treatment we can remove that. Otherwise, what will happen? Septic condition or odor problem we will have. Okay, so we do not want to have this organic compound to be settled down. So if we are having retention time more than 3 minutes, then this excessive organic material will also settle down, and this will give you the septic condition. So to avoid this kind of condition, the retention time should be of 3 minutes. So just see, uh, whenever we are treating the wastewater, the water retention, so this is kind of hydrological engineering is very important. So there must be calculation to find out this 3 minute, so that we can have the organic compounds in suspension only. Okay, so after that grit chamber, we have one more equipment that is known as the equalization tank. So the primary role of mixing in an equalization tank is to, and we have four options here: increase dissolved oxygen for biological oxidation before primary treatment, maintain solid in suspension, prevent septic condition, and ensure uniform load to downstream unit, promote flocculation and sedimentation before secondary treatment, reduce the concentration of toxic substance through chemical neutralization. You already have given me answer. Dia and Priscilla okay, gave me B answer. So yes, this is equalization means you are equalizing the solution, or you are making the solution uniform in nature. So that's how equalization tank is used. So this is something like this. To make the solution, or to make the wastewater uniform, we have to pump some air, and that's how it will mix your everything in a uniform way. Okay, so this is the equalization tank. Why does installing an equalization tank often reduce the capital and operating cost of downstream process? Why it is very much important for us to reduce the capital and operating cost of downstream process or the further processes? Because equalization tank directly removes 60% of solids and 35% of BOD, because flow and load variation are buffered, allowing downstream unit to be designed for average instead of peak loads. Because equalization tank remove heavy grit and screening, because aeration in equalization tank fully stabilize wastewater before biological treatment. I think you already have given me, Dia, Priscilla, you gave me answer B. Yes, this one is the right one only, because here the load and flow variation will be buffered. So everything will like your, from different places you will have different flow or different load, so everything will be mixed, everything will be uniform. So whenever we are talking, whenever we will go to the further step, we do not have to care about from where this load is coming, at what flow it is coming, because we are mixing everything. We are uh, from anywhere it is coming, so we are having uniform wastewater now, and so that we can design our downstream technique based on that buffered solution only. Okay, so the next is uh, in equalization tank, we are using air pump, right? So it means we can use aerators. And one of the, so we, in a very different way, we can give air to your wastewater, and one of this way is diffused or injection aerator we can use. So in diffused aerator, the depth of water play a critical role in design. Which statement is correct? Diffuser must always be placed at the bottom of tank irrespective of depth. Diffuser must be placed at 3 to 4 meter below the surface. If depth is more, extra diffuser are required. uh, Tank width must always be double its depth to ensure uniform aeration. Time of aeration is typically less than 5 minutes for adequate oxygen transfer. Venkateshwara gave me answer C. What do you think? What is the right answer for this? So we are using different type of aerators in the equalization tank so that we can make the uniform wastewater, right? And the one of the aerator is known as the diffused. So can you tell me where it should be inserted? So answer is B, but not the C. That it should be placed at 3 to 4 meter below the below the surface. If depth is more, extra diffuser are required. So let me show you different aerators we can use. This can be gravity aerators, we can use fountain aerators, we can use injection or diffused aerators, or we can also use mechanical aerators in the equalization tank. And because we were using about this one, so the tank is kept as tank depth is kept as 3 to 4 meter, and tank width is within 1.5 times its depth. And this is how we can adjust at the depth at which we should have the reactors. So you can read about this. Okay, now coming to the sedimentation. So you have to tell me which of the following incorrectly describe the sedimentation. Just see the word incorrectly. And here we have greater particle size and density, faster settling, higher water viscosity at low temperature, slow settling, excessive turbulence, enhanced particle aggregation and settling, flocculation, large particle size, increase settling velocity. You have to tell me the incorrect statement about the sedimentation. Okay, Venkateshwara and Diya gave me option C. Okay, so yes, answer C is right, because whenever there is a more turbulence, so aggregation and settling will not happen, because every time particle will be in suspension because we are giving them the turbulence. So this is the wrong statement. So this is something is the sedimentation tank. So here will be settling, and this settling will be moved out, and the water will be go for the next step. Okay, there are also some factors that can influence the sedimentation. For example, density. Whenever we have greater density of the particle, then the particle will be settled down easily or faster. Size, whenever we have size larger, then it will be faster that they will settle down. Temperature, lower the temperature, higher the viscosity, slower the temperature settlement. Turbulence, more turbulence, slower the particle settle. Stability, instability can result in short circuit flow. Bottom score, during bottom score, settled particle are resuspended. And flocculation result in in the larger particle, and that will increase the settling velocity. So these are different factor by which sedimentation will be impacted. Okay, so we do have different zones or different region for different type of settlings. So we may have discrete settling, flocculent settling, zone settling, and the compression settling. And different settling are taking place in different chamber or clarifier. It can be grid chamber, it can be primary clarifier, it can be secondary clarifier, or it can be sludge thickeners. So can you give me the correct application type of settling with their correct application? What type of settling is needed at what place? Venkateshwara and Diya gave me A answer. Uh, yes, A is the right one. Discrete settling, then we can use it in grid chamber. For flocculent settling will be happen in primary clarifier. Uh, Zone settling will be happened in secondary clarifier, and compression settling will be happened in sludge thickeners. Here you can also see discrete settling region, flocculent settling region, hindered, or this is the compression region. This I should skip. Okay. In which type of settling does particle concentration become so high that lower layer support the weight of upper layer, forming a compressible structure? Discrete settling, flocculent settling, hindered settling, compression settling. I think from the word that I have in the question only, you can guess something about this. Okay, so you people gave me D answer. Then yes, yes, D answer is the right one, because here also you can see depth. Whenever there is a more depth, here is the depth and this is the time, right? So this is the zone of your compression. And so this will be, it is something like solidifying your waste material. So this will be your compression settling. Okay, in water pollutant, we already have discussed this. We have two type of velocity. The one is your settling velocity, and another is your original velocity that you have of the particle. And if we want to remove 100% of particle, what criteria we should have? Based on that, we need to design our settling chamber. So let's say this is your settling chamber. Again, you have some particle and you need that particle to be settled down here. And the velocity, it will be v naught, and the velocity, that is the settling velocity, will be vs. So we have to design our settling chamber in such a way that this settling velocity vs should be more or equal to v naught. Okay, so you have to tell me the design criteria. L is for the width, so this is L, this is your H. So can you tell me which one is giving you the right statement? As I told you, the time taken for this, so just assume this is your horizontal flow, and this is your vertical flow. Okay, so the time taken for your vertical, the time for the vertical should be less than time taken by horizontal direct in the horizontal direction, right? So because this is the only way by which we can settle, because the time to settle down in the vertical direction is less as comparison to the horizontal direction. So this t, you know that time is speed is equal to distance upon time, distance upon time, and then time is equal to speed upon or v upon d, distance. So based on that, if you are calculating vt, then vt will be v settling velocity upon h, and the time for vh will be v naught upon l, and this situation is given. So based on that, you can tell which one is the right one. So the right one will be d option, right? Is there any problem with this? So d option is the right one. Okay, the next, what we are using in the primary equipment is dissolved gas flotation. And in dissolved gas flotation, nitrogen gas is preferred over air because it increases bubble size for better flotation. It reduces treatment cost. It eliminates the risk of explosion in oil industries application. It increases solubility of gas in water. Okay, so I have answers. Priscilla gave me C and Dia also gave me C. Yes, this is right. Uh, we are giving some gases, dissolved gases to your wastewater. Next question is based on that, why we are giving that gases to your wastewater. But the thing is, nitrogen gas is mostly given, and this is because it is inert in nature. In the gas we have oxygen also. If we will give that oxygen, that will increase the case of the explosion. So we are giving the nitrogen gas for the flotation. So C answer is the right one. So this is something, we have this chamber and we are giving some gas, we are giving some gas to your wastewater. So what will happen, we will have oils, let's say these are the oil, uh, or some particle that is very lighter in nature, so that will be floated, and that floated particle will be removed by the skimmers. So this is how whenever we will have oil particle or something very lighter, so we will give that air to your wastewater. This is how that will come on the top, and this will be removed by the skimmers. So that's why we are using this flotation and nitrogen gas in that flotation. Okay, so we are done with our primary treatment. We have talked about this all. Now we are moving to the secondary treatment. And for the secondary treatment, we do have different type of secondary treatment, different process. In that processes, we have lagoon system, we have aerobic digestion, we have activated sludge process, we have anaerobic digestion, we have UASB, biofilter, and microbial growth, and like the retention time for this microbial growth and the wastewater. So this will come under your secondary process. So I have few question on this secondary treatment. Then it will be done. Okay, so in the wastewater, we already have done this primary treatment. we have used all this grit chamber, equalization, and sedimentation. Then in secondary treatment, we will use a microorganism to remove the organic compound from the wastewater. That's why we are using secondary treatment. So main purpose of secondary treatment is to use the microorganism to degrade the organic compound from the wastewater, because many of the industries have a lot of organic compounds. Okay, so the question is, in wastewater treatment, the main role of secondary treatment process is to physically remove grit, sand, and floating debris, to chemically precipitate heavy metals and dissolve salts, to biologically degrade organic matter and transform nutrients using microorganisms, to sterilize wastewater and completely remove all pathogen. You all gave me answer C, and yes, answer C is right, because A answer is all about the primary treatment. B answer is about primary treatment and the tertiary treatment. C answer is about the secondary treatment. And to sterilize wastewater and completely remove all pathogen, this is the part of tertiary treatment. So C answer is the right answer. Okay, so we do have different type or different technique within our secondary treatment, and we can use aerobic and anaerobic secondary treatment. So how you will differentiate, either you are using aerobic secondary treatment or anaerobic secondary treatment based on the product that will be formed in your wastewater. So among A, B, C, D, tell me the right answer. So aerobic process require free oxygen and produce CO2 and H2O and biomass. Anaerobic process occur without free oxygen and produce methane, CO2 and biomass. Aerobic process require no oxygen and produce methane. This is wrong, because aerobic means we are using oxygen, we are giving oxygen to the wastewater, because some of the microorganism need oxygen and some of the microorganism do not need oxygen. Okay, so whenever we are having microorganism that need oxygen to degrade the organic compound, we are having aerobic secondary treatment. But whenever we are using microorganism that will degrade the organic compound in the absence of oxygen, that will come under anaerobic respiration, anaerobic secondary treatment process. So whenever it is aerobic, so all the product will have oxygen, right? So it will be carbon dioxide, it will be water, or it may be biomass. But if it is anaerobic, it means here we will not have oxygen, so mostly we will have the methane production along with little amount of carbon dioxide, because organic compound also have uh, oxygen molecule in it. So that's why it will give also some of the CO2 and the biomass. So that's how A is the right option. Which type of microorganism has been most extensively used in secondary biological wastewater treatment process? Fungi, algae, bacteria, yeast. Okay, so everyone gave me C answer. Then yes, most of the time we people use bacteria to degrade the organic compound from the wastewater. Uh, in wastewater treatment, we can have microbe in two form. So you have to tell me these two form, in which in these form we can have microorganism in the wastewater: suspended form and attached, suspended growth and attached growth, aerobic growth and anaerobic growth, primary growth and secondary growth, settled growth and floating growth. B is not the right answer actually. Yes. So A is the right answer. here we are talking about the growths. So these are either we have microorganism suspended within the wastewater. So either we are uniformly distributing the wastewater microorganism in the wastewater. This is the first thing. The second is we can have something like if we have some rotating things, or let's say we have some surface, and on that surface we have microorganism, and we are percolating water into that, and then water, purified water, will come out of it. So this will be attached. So we are attaching our microorganism on some surface. That will be the attached growth. And suspended will be in wastewater we have microorganism, irrespective of either we have surface or not. Okay, so that's how A is the right answer. So just see here, this is your water, and if we have some surface, on that surface we have microorganism, or you can say we have the film of microorganism, then this will be attached growth. And if we have bacteria or microorganism in all the water, wastewater, then this will be your suspended growth. Which of the following is not considered a conventional secondary treatment option? We have conventional and non-conventional. So conventional is we are using secondary treatment in ancient time and very much exploited. So this will come under conventional. But non-conventional means we are using some different technique. Based on that, we are having this secondary treatment. So you have to tell me which of the following is not considered conventional. Lagoon is conventional actually. Lagoon is nothing but a lake, or you can say the wetland that have a very shallow depth. So in that shallow depth, we can like there will be microorganism and we will have air. So with that air and microorganism we can degrade the organic compound. So this is lagoon is very, and like we are using lagoon from ancient time to remove organic material from wastewater. So Tia gave me C answer. Yes, C is the right one. We are right now we are using membrane biofilter as well, one of the non-conventional secondary treatment option. And anaerobic digestion is also we are using from thousand of years. This is something like we are having the water and we are not giving the oxygen to that water, and this is how some of the organism will thrive into that, and that will decompose or degrade that organic material. So just see here, if we have conventional treatment options, so this will be lagoon, aerobic digestion in the presence of oxygen, activated sludge process. So this is something we talked about, water and organism in all the water. Anaerobic digestion in the absence of oxygen. UASB, we will talk about this. Biofilters, so we have some filter that is made up of the biofilms. Advanced treatment option, we have granule activated sludge process, sequential batch reactor, membrane bioreactor, uh, FICO remediation. This should be phyto remediation. Okay, FICO and FIRO is different. So FIRO remediation, I do not know much about this FIRO remediation. You can search about this. Then phyto remediation, and we have bioelectrochemical system. Okay, so the next question is advanced secondary treatment option include UASB, biofilter and lagoons, aerobic digestion, activated sludge, anaerobic digestion. C option is membrane, biofilter, pyro, remediation, bioelectrochemical system, septic tank, Imhoff tank, and trickling filter. So yes, C answer is the right one. So these are very advanced secondary treatment option: membrane bio reactor, remediation, and bio electrochemical system. So C is the right answer. Okay, which of the following is an example of attached growth aerobic secondary treatment plant? So the first thing is, microorganisms should not be in suspension, they should be on some surface. So these are attached and aerobic also. Okay, Priscilla gave me answer C, that is the trickling filter. Dia also gave me. So yes, C is the right answer. If we are talking about the activated sludge, these are not attached, but these are in the suspension. Aerated lagoon also have microorganism in all the water. Trickling filter is having the surface on which we have microorganism, and then we are filtering our water through that attached microorganism filter. Aerobic digestion is also not the attached growth uh, secondary treatment. This is suspended. So here you can see, if we have the suspended growth, so first, if it is the aerobic process, in aerobic process also we can have suspended growth, we can have attached growth, and we can also have hybrid. In the suspended growth, we will have activated sludge, aerated lagoons, stabilization pond, aerobic digestion. But if we are talking about attached growth aerobic process, then this will be trickling filter, rotating biological contractor, packed bag reactor. And uh, the processes, aerobic processes, where we do have suspended as well as the attached growth. So this will be the trickling filter and activated sludge. But if we are having anaerobic process, in anaerobic process we also have suspended growth and attached growth, and these are different examples. So here it will be anaerobic, right? And we have also lagoon processes. In that lagoon processes, so lagoon is something, you have some pond, that pond have the shallow depth, and you are having water in that pond. So automatically over the year, using some microorganism, natural microorganism and the sunlight, uh, biodegradation will be happened. But lagoon can be aerobic. Some of the place of the lagoon will be aerobic, means there is the presence of oxygen. There will be maturation lagoon. Facultative means the transition where we may have oxygen and where there is like absence of oxygen also. Anaerobic, so at the bottom of your lagoon, where we will where there will be no contact of your oxygen with the microorganism. Okay, so these are the different region or different type of lagoons we can have for the treatment of the wastewater. Okay, a system that combines features of both suspended and attached growth process is called. So yes, as we already have discussed in the last slide, this is trickling filter and activated sludge hybrid. Okay, which of the following pond relies on algae and wind-induced surface mixing to provide oxygen, while some anaerobic activity occur at the bottom sediments? Aerated aerobic pond, aerated facultative pond, aerobic facultative pond, stabilization pond. Where algae, so just see, algae are having oxygen from the atmosphere. So this is uh, the aerobic region. Okay, and whenever we will have the anaerobic activity, because sunlight will not be present, atmosphere will not have direct contact with the bottom, so there will be the absence of oxygen, so this will be the anaerobic. So based on that, aerobic facultative pond it is. Okay, so C answer is the right one. So just see here, uh, At the bottom we will have anaerobic bacteria, at the top we will have the aerobic bacteria, and the figure you can see below is the example of lagoons that we may have. And these are different properties of aerated aerobic lagoons, aerated facultative. You can read about this later. Which type of pond system have the highest O&M cost and require skilled labor for equipment maintenance? So this will be the aerated aerobic pond. So first it should be the aerobic pond. Then we have to put more oxygen into that. So we have to make it aerated pond. So to make that, the cost will be very higher. So that's why D is the right answer. In which type of pond is sludge removal typically require only once every 10 to 20 years? So this will be aerobic facultative and aerobic. Okay, in aerobic digestion we use some microbes, and one microbe that can oxidize iron 2 to iron 3, and the example is Gallinola, which is not the basic requirement for successful aerobic digestion, and this is the presence of toxic industrial chemical. I think this you can read about activated sludge process. And this is about the UASB. So what COD and BOD value we should have. And this one question is about biofilter. This is about the biofilter, and this is how we um, end this lecture. So thank you so much for showing your patience. We will meet again from 7 to 9. If you have any query or suggestion about the pace or about the content, you can let me know. You can anytime mail me on my email jyoti21 at the rate iiserb.ac.in. If you have any query, you can put that query on my email. I will try to give you answer as soon as possible. And this is the dinner time. You can go and have your dinner. So thank you so much. Good night, everyone. If you have any problem or query or suggestion, you can let me know. So thank you so much, Priscilla. Good night.